Good morning. I am Nicole Testa Boston, the Deputy Director of the FIATEC Consortium. And on behalf of all of us at FIATEC, I'd like to thank you for joining us today for what marks our 85th live webinar. Today we have an exciting hour set aside to discuss Chimbro's success at integrating high-definition surveying directly into real-time construction sites geomatics, and for which they were recognized in March with a SETI Award in the Intelligent and Automated Construction Job Site category for this achievement. So with that, I want to go ahead and welcome and introduce our two speakers. Seth Goucher is an 8-year veteran and chief field engineer for Chimbro and a third-generation Chimbro employee residing in Maine. He holds a Bachelor of Science degree with an emphasis in forestry from Unity College. He is accredited in introducing Chimbro to the spatial data collection capabilities of HDS technology. Some of the high-profile projects Seth has worked on over his 8 years with the company include the Portland International Jetport Parking Garage, the Amethyst Semi-Submersible Dredging Rigs, Dragon Cement Wet-to-Dry Conversion in Thomaston, Maine, the Athens Old Town Boiler Relocation in Old Town, Maine, the Penobscot Narrows Bridge and Observatory in Prospect, Verona, Maine, the Landfill Gas to Energy Project in Hamden, Maine, the Brightman Street Bridge in Fall River, Massachusetts, the Eastern Maine Medical Center West Parking Garage in Bangor, Maine, and the Eastern Manufacturing Facility Site Development in Brewer. Braden Sheave is a 2-year veteran and field engineer and HDS technician for Chimbro. He recently graduated from the University of Maine with a Bachelor of Science in Construction Management Technology Engineering with minors in Surveying Engineering Technology and Business Administration. Some of the high-profile projects Braden has worked on in the past 2 years with the company include the Penobscot Narrows Bridge and Observatory, the several hydro and electrical dam projects in Maine, the Motiva Port Arthur Crude Expansion Project in Brewer, Maine, and the Gulf of Maine Research Institute Pier Replacement in Portland. So with that, I want to go ahead and thank both Seth and Braden for joining us today and sharing your story with us.
Sweet. Good morning. Thank you. And we'll get going because we don't have a lot of time. This is a company overview. We're a heavy civil, mechanical, electrical company. We do many facets of construction. We do power generation, hydro and dam, transmission, distribution, modular manufacturing, which we'll see more of, fab and coating, industrial fab, marine, shipbuilding, transportation, institutional and commercial work, waste and water, and pulp and paper stuff. We have some geographical locations. Our corporate headquarters are in Pittsfield. We range mainly up and down the East Coast, and we have in about for the last 60 years, and we're currently getting ready to expand. So this will give us an HDS overview. I think this is a video, and it will kind of roll through some of this stuff that we've done at our facility and should set up a good base. So.
In 2007, Chimbro Corporation converted an idle paper mill in Brewer, Maine into a state-of-the-art module manufacturing facility. Chimbro team members produced massive refinery expansion modules, steel frames filled with pipe, electronics, and other components that become the building blocks for the largest refinery expansion in North America. The Leica Scan Station 2 and Cyclone HDS software have been essential in completing this vital project.
were closed, we started to take over the pad and start construction. So we took everything from state plane coordinates, switched them to a local coordinate grid for ease of construction. We made everything straight with the pad, and we started with a 5,000 grid so we can locate everything on the pad. Once the grid was established, we then generated an AutoCAD drawing of where we wanted to place the first set of modules, and then we went out and we started to locate those points traditionally with the toll stations that we have. And we started to paint the baselines, and we used the engineered feet that we were given that are made out of 14-inch H-pile, and we started to set those within like 3/8 of an inch of where they're supposed to be so we could start erection.
Once we've determined where we're going to place the module out in the yard, 2 of us or 3 of us will go out and paint the column line intersections on the ground. And that just shows the crew and us where each structural base foot is going to sit on the ground. And it gives the upper management an idea of where a module is going to sit, if it's going to work with the subs and the heavy hauler company as far as moving modules around site into the barge.
Once the bases are set, we set these shoring towers up. The shoring towers help hold the transport beams, which the heavy haulers will back under and pick the modules up. And then we set those to an elevation. We typically try to keep those 4 to 5 feet off the ground. That's the ideal height off the ground for the heavy haulers to back under them with ease without having to jack it up and then lower it before they move. The shoring towers hold those beams, and then we fly in the vertical beams to set those in place on top of the base feet that are preset. As we erect the steel, we also fly in pipe, and it's called lasagna style. As we put in the layers of steel, we have to put in the larger pieces of pipe because they won't fit. When we first started, we tried to stuff them in from the side, and it took a lot of time, and obviously it's a lot more risky. So now we erect this, it's called lasagna style. We'll bring up the first elevation of steel, rough locate all the locations, and then the iron crews will fly in all the pipe components that are on that level, and then we'll continue on with erection. Once the whole module is erected and most of the pipe is laid in the rack or in the process module, we'll look at it for plumb, verify it, and then the torquing crews will go to torquing. Once they're torqued, then we'll do a structural sign-off to verify that spatially it's square and plumb. To verify square and plumb, we'll go out traditionally, survey some base plates, set up a grid control with 2 points, and then we'll take the scanner out and we'll scan from 4 points around the module and then constrain to a point cloud, and we'll extract the data from that. In the structural steel sign-off, we have to verify every piece of horizontal steel for elevation, and all the vertical columns need to be located for location and for elevation. So the scanner helps us collect that. If we didn't do it through the scanner or the HCS software, we'd have to do it traditionally. And that could take a few days with a man lift and 2 guys in a basket trying to shoot elevation and vertical columns and try to tie it all in. Plus, this also all happens while the crews are working, so it's very dynamic, and it changes day to day.
The scan station allows us to collect all the data we need for the structural sign-off right from the ground, from 4 setups on the ground. If we were to do the structural sign-off conventionally, it would consist of 1 person on the total station and another person up on the prism, you know, right on the edge of the pipe or right on the edge of the beam, which is 40 or 50 feet in the air, and all types of weather, you never know. So the scanner allows us to collect data in as safe manner as possible with minimizing our risk, which is a big deal for us.
The scan station gives us the ability to stay off from the steel in foul weather. The steel gets very slippery, no matter if it's rain, snow. It gives us the ability to scan the module from the ground. There's no way that we can slip off the steel while scanning the module from the ground.
The HCS technology allows us to provide technical support to up to 500 craftspeople on site, iron workers, pipe fitters. We can provide them with all the spatial information they need to complete their daily tasks. And we can do that with a minimal crew of 2 to 3 people because of the productivity and efficiency that the scanner is capable of.
Once we collect all the data in the field, we'll bring it back, constrain it, put it on the XPS workstation. We'll start to work through all that and extract the data points that we want. We have a preloaded Excel sheet where we've made the table and the desired points from the CAD program that we initially had for the layout. We'll take all those points, compare them theoretically in our Excel sheet, and then we wrote a conversion to convert it all to port optic coordinates, which is That's the only data information that was supplied to us to start with.
As a module fabrication yard, we are supplied with drawings that have plant coordinates on them that are in direct relation to the locations of the future modules in Texas. These modules all have a reference point at one column line intersection per module. From that column line intersection, all the pipe and structural steel is fabricated.
So they give it to us in Fort Arthur coordinates, and we'll deliver the final product back in Fort Arthur coordinates. Once the point cloud is all constrained and put in, we'll extract off the base plate information that we want. We'll put that in the Excel sheet that has the theoretical locations put into it. We'll then take those, compare them in the Excel sheet, convert them to Fort Arthur coordinates, and that will give us the variance, and that will tell us if the module is plumb, square, level, and within spec. If it's within spec, that's good. We verify plumb within 5/8, check that off on the sign-off sheet, and then we go to horizontal framing. We go through the Cyclone software and pick all the horizontal framing members within probably 2 or 3 different spots on each horizontal piece of steel. And then we verify that as well. That has to be within 1/4 inch of the design height so that all the piping components will fit, and those are within tolerance. Once the structural steel is all signed off and we've verified everything's good, the crew will go out and we'll put offsets on the module. We put them on all the cantilevers and we put it up the middle, and that helps the craft people locate where the piping goes. It has to be within 1/8 of an inch, so we need really good targets to shoot for. Once the offsets are on the module, we give the piping crews the go-ahead to start fine alignment and welding and assembly of all the components. Once all the components are done and all welded up and finished, we do a final verification survey.
We are provided with ISO drawings that have pipe end locations on them, X, Y, and Z values in plant coordinates. We then transfer that into our coordinates on our local pad. We use those to compare what we get in the field. We have a lot of data that we need to crunch. So as a check and balance, we use the scanner and the software to visually view our data. It gives us the ability to have a much more visual analysis versus a quantitative analysis.
Using HDS has allowed us to work on site with a small crew. We can be very efficient. It also has allowed us the flexibility to work off-site. By working off-site, we mean we work with other timber jobs. We help supplement them if they have issues, and we can also go in and help solve other problems or just supplement them with geometry control and everyday layout as well. That's a big help too to a company.
All right, so good. So there's a good little overview of what we did at our Motiva site. That video is available at chimbro.com, and there's some other information there when you look into it and kind of help to bring you up to speed on that. Here's some project specs: 180,000 lineal feet of pipe, 9,000 tons of structural steel, 24,000 welded connections. We completed 51 modules, and it all became within an 1/8 inch tolerance. This was our typical scope of work. This is what we kind of handled. A typical rack has around 230 tons of steel, 5,200 feet of large bore pipe, 1,000 feet of small bore pipe. And they had anywhere, somewhere around 135 interface points that we had to survey and compare. They had 260,000 bolts, and we typically collect about 15 million data points to constrain and fix all this stuff and quantify it, sign it off. We'd verify all the structural steel column locations, plumb, square, and elevation of all the horizontal framing. And then we determine the record location of all the module interface points in relation to the client-supplied design values, which is just a direct comparison of the theoretical. Some of our benefits, obviously we don't have to work in hazardous weather conditions. We can kind of schedule our scanning around that. So if a storm's coming in, we can either hurry up and scan and work inside while it's raining or snowing. There's a whole pile of thousands of interface points that had to be looked at. The tight tolerances. The tolerances on this project were almost so tight that conventional survey wouldn't allow us to survey a whole module in time or in a day to get accurate data. We had real aggressive production goals on this project, so speed and versatility is definitely a factor. We had a limited fabrication area. In about an area of a 500 by 500 square, there was around 300 to 500 craftspeople plus equipment and modules, and a lot of stuff happening at once. And obviously we were erecting more than one structure at a time, so this helped out a lot with that. It keeps our technicians off the module. It allows us great repeatability, allows us to get traverse closure reports. We had a crew of only 3 instead of the predetermined. We had 9 or 10 people slated for this project. We could scan from different locations. We didn't have to survey from fixed points. So if something was in the way, we could always just change the control point. We got accurate 3D models of all the spatial data, and obviously multiple scans of single modules. Here's some other project we completed while we were doing the Motiva project in our spare time. We did a riverbed dredging and bulkhead construction plan, which was just we did a volume calculation and an actual volume determination of what was dredged out of the river after it was all dressed up and done. This was more of a fun project, but we actually had to determine the angle of the helicopter so that it was actually a real-life approach angle. So we had to, once it was erected, we just verified that the actual pitch and tilt of the helicopter was actually at you know, the way they actually fly them. We did a lot of parking lot drainage design and some underground utility stuff here. This is one of our fab shops that we took like an abandoned warehouse and turned it into a pipe fab facility. Dam remediation. We surveyed this before it was remediated, and obviously we don't have any pictures, but after remediation, this became Atlantic salmon habitat. So we took the dam out and put in some boulders and riprap and whatnot for baby salmon. Noise reduction design. This was actually a pretty neat little project. This is actually our fab shop in Pittsfield. Some of the neighbors were complaining about noise, so we actually went in and surveyed our whole yard and could quantify all this data and give it to some noise design engineers to determine what size retaining wall and what material they need to construct it out of to reduce the noise level going across the street. Asset liquidation. This was obviously the bread and butter of what HDS was made for. We've, surveyed various, aggregate piles and stone piles for, pretty accurate volume calculations. So when we do purchase this stuff, we actually get what we're buying. Go ahead, Braden. You can talk about this one. This was your project.
All right, thanks, Seth. My name is Braden. Just hopping in here. Just going to go over probably the end of the slideshow. Marine fixed structures. We do several projects involving marine work. This is a pier project that I'm currently working on in Portland, Maine. You can see in the lower left-hand corner, we had to come in and demo out an old timber wooden pier, and we're putting in a new one, but they left a remaining sheet wall that was underneath the timber pier, as well as obviously some of the timber. Some of these piles travel anywhere from 50 to 100 feet into the ground. And on the upper right-hand corner, there's a picture of the new steel pipe pile that we're driving. And on top of that will be concrete pile caps and then a concrete deck. But in order to determine what was going to be in the way timber-wise, we had to go scan before we started driving steel pipe pile so that we could get rid of any timber that was in the way, as well as the sheet wall and any interferences there. It was a very useful tool, and we did have some things in the way that we did have to remove. This is another project that Seth actually went and scanned, electrical transmission work that we do. We had 4 towers that were typical to each other that needed to be deconstructed, as well as 2 other towers that were typical. Our engineer, Bob Courtney, within the company, actually questioned using the scanner for something like this. We ended up not having any shop drawings for the towers that needed to be deconstructed. So there was no way of knowing the weights of the steel without going up there, climbing around, getting dimensions, getting steel thicknesses, and things like that. We went and scanned it in a day and took about 2 to 3 days to come up with a deliverable as such. And you can see on the table on the right-hand side, our engineer was able to decipher the data and determine what he was going to do for a deconstruction pick plan. This is just some minor road work that we did for a local engineering firm. They had a drawing in the left-hand corner that they had, and they wanted to determine, make sure all the curves were where they were, manholes. It was a very busy intersection in Brewer, Maine. We did it at 8 in the morning, so it was rush hour. We were able to just clear out the noisy data and still collect all the data that needed right from the sidewalks.
All right, and this concludes it. Special thanks to Chimbro, Leica, Motiva, and Fiatech. So I think we're going to open it to questions now.
Great. Thank you very much. A couple questions here. Are there any issues with measuring tolerance in the cold winters of Maine, and likewise having the modules installed in a place like smoking hot Texas?
We have predetermined growth analysis on piping, so we can put that in as a target, so we can get accurate locations. Obviously, it will be different here than it will be down there.
We actually used the scanner. I always go back to this example because I was actually left alone on this day. You know, I give Seth heck about it every day, but it was actually snowing quite hard, and I was able to scan an entire module, and we actually got all the data that we needed. So it's very, very versatile.
Thank you. How did you verify the 1/8 inch tolerance in the scanned model on the Motiva project?
We were supplied the northwest and elevation data. We wrote an Excel sheet to make those interface points compatible to our pad, and then we obviously would direct the steel to the coordinates that we wanted, and then we would obviously survey it, model the last 6 feet of the pipe, and then we would pick that interface point and then compare it.
If you look on the screen right now, just at the bottom of the scanner, you can see there's the blue vertex from the model data. There's also a yellow dot right below that, and those are the points that we entered into the Cyclone software. So we had a visually, you know, we could compare right there, but like Seth said, we also put it into an Excel sheet for our client to see.
Great, thank you. Next question. Scanning providers that this company talked to say things like the standard deviation of the error of points in a point cloud is 6 millimeters. But in the promotional information you talked about 1/8 of an inch tolerance. How do you do it?
Yeah, that 6 millimeters is out to, I believe, 300 meters. And our modules were only, I think the longest one was 100 feet. So by taking multiple scans, we can also ensure and quantify our data that it's actually good. If we scan it from 4 different spots, you'll have 4 different point clouds that are constrained into one to give you a good best fit of where the locations are.
Great. Next question. Do you use the scan to generate an as-built in the BIM software?
Right now, on this project, we didn't have BIM software. I think that's kind of a misnomer, but we use Cyclone software, which was provided by Leica, and we interface that with our regular AutoCAD 2008 license, and we could quantify our data that way. That's what we use for software. We didn't use it with ConstructSim or any of the other software that we had generating work packs and such. Maybe next trip through.
With the Cyclone software from Leica, we did have the ability to model an entire module if need be, anywhere from the bolts to the structural steel to all the piping.
Thank you. Next question. What has been your experience combining scanned data of an existing structure with a new 3D design and the ability to manage the resulting large file size?
File size is always an issue. A lot of external hard drives. We have a backed up server that Chimbro actually have our own server. We put all our data on. definitely bogs down your computer, and we definitely need to, you can compact and condense all your data, and as long as you archive it, you can clean that out of your working desktop or whatever, and helps the performance of your computer. File size, they're big, so we try to collect just enough data that we need. We try not to do like a full resolution scan of everything. We try to only do super high resolution stuff for this project, such as pipe ends and base plates, and collect enough data on the structural steel that we can analyze it, but we don't have so much data that, the file sizes are almost unreal.
Thank you. You said that you scan the base plates to make sure they are in the right location. How did you change their locations and re-verify? What was the work process there?
All right, Braden will answer this one.
Actually, it was quite a bit of work on our construction team's part. We used power packs that could actually lift a column on a module, and then we put the base plate on rollers, and we would come along them around or use some sort of engineered method.
Change balance.
Yeah, and that with the modules being on our pad, we had the ability to adjust our values for our theoreticals if we had to. These modules weren't bolted down. They were just sitting on shim pack without anchor bolts on our yard, because obviously they were going to be moved to a new location for their final resting place. So we had the ability that if we could adjust our values and theoreticals for our reference point to make everything come within tolerance, we would.
Great, thank you. How did you scan pipes that are not visible from the ground once the floors were in?
For this project, most of the interface points were either underneath it, so the lowest transport beam was roughly 5 to 6 feet off the ground, so we could scan underneath, and probably 99% of the interface points were on the outside locations where they'll tie to another module. So everything, we'll just say that's inside, was not necessarily not relative, but didn't have such a critical tolerance, we'll say, as the pipe ends did.
Thank you. Do you model inside Cyclone or inside AutoCAD?
We tried to do both, and Cyclone software seemed to be more user-friendly for my crew and me. Obviously, we're not drafters, so that's kind of a, we're a field crew, so it's kind of hard, not having a large drafting background to get right into AutoCAD and dig right into it. Cyclone was pretty user-friendly, and it seemed the quickest, easiest avenue of using their preloaded tables.
Thank you. How did things go when the modules were installed in Texas? Did the modules fit up okay?
So far, so good. We've gotten an A-OK from the client. They were very pleased with the quality of product that they received.
Let's see. Do you have any feedback from the site for Motiva to verify that piping is actually on location in the module?
I think we have limited, or at least Braden and I here, limited feedback. I know our project manager has heard numerous times that our modules, out of the 4 module yards, our stuff looks the best and the tightest. I have not personally got a phone call, but I've had several emails saying that your stuff looks pretty good and you guys do pretty good quality of work.
Can you repeat that question again?
Yeah, I'm sorry. I'm not really fully understanding it either. I guess, do you have any feedback from the site for Motiva to verify that the piping is actually on location in the module?
Yes. When they receive the modules, there's crews there, because these get C-fastened to barges and then go around, basically the East Coast and arrive. So actually, out of all the module yards, we have not had one incident. They've actually asked Chimbro, they sent some of the other yards to come up and take a look at how we fastened all of our pipe, and also the extra materials that ladders and maybe some gangway stuff that would be attached later on. We would just attach them to the modules to go down.
And further follow-up from the same individual, I think what he was saying is, do the pipes line up at tie-in?
Yes. We have not had one incident so far. Everything's tied in perfectly.
Thank you. Let's see. Do you install fixed targets for control, and do you use a combo target for the HDF scanner and the total station verification?
Okay. We use the Leica 3x3 stick-on targets. We stick those on the structural steel to help constrain the point cloud, but we use the traverse method, so we traverse around the module, and that generates a closure report, and that's how we can quantify our data.
It also gives us the ability, going back to us having to use our local coordinate system and compare northings and eastings to northings and westings that we've been given from the client. With the closure report, like Seth said, that gives us, that tells us, if our closure is within tolerance or not, and then we can actually go work with the data, and like I said, we have northings and eastings on our local pad that we can work with, not just random, arbitrary 3D points.
Do you have a type or model of scanner that you prefer?
Well, we haven't tried a lot of other ones. We demoed a few others. Leica, seemed to be the one of choice, and that's the one we have, so that's the one we use. The new C10 obviously is a little bit faster and a little more efficient. There's no cords, onboard batteries and such, but someday maybe we'll get there. Right now we have an SS2, and that's what we got.
And we also use Leica Total Station, so it was kind of a compatible work for us to go with the Scan Station 2 as well. And like Seth said, it's very versatile. With the amount of work that we do as a company and the different industries that we hit, to use a phase-based scanner wasn't really what was going to work for us at the time.
Thank you. Can the point clouds pick up underwater data, and is the scan station waterproof?
Is the Scan Station waterproof? We've had it in some mild weather. We try to not, obviously it costs a lot, so to put it out in the weather is not really in your best interest. Moisture also can contaminate your point cloud. You can actually see all the particulates in the air once you get your scan data, and it makes it hard to read, so it's actually in your best interest to not scan on rainy days, foggy days, such as snowy days maybe. Underwater data, we haven't had to collect any underwater data. If it's below the tide line, we'll wait for low tide and then we'll scan it.
So presumably it's not submersible.
No.
I wouldn't dump it in the ocean.
We're probably not going to put eyes in anytime soon.
Okay. Were there any surprising challenges in completing the modules? Sorry, were there any surprising challenges in completing the modules?
I think one of the greatest, challenges for me personally was getting people to buy into the technology, really. People in our company and in the construction industry, I believe, really buy into, obviously, total stations, but that was obviously a work in progress. Me being kind of newer to the industry, a lot of guys that have been in the industry for years and team members that have been in the industry and done it one way or another for the entirety of their career, it's really hard for them to see somebody come out here with, I don't know, I've heard it called several different things, but to come out with some sort of technology like this, scan a module, walk away in 4 hours, and then come back and tell them within another couple hours that, geez, you have some work that you need to do on your module was one of the most difficult parts for me.
Thank you. What file format do you provide your final 3D models?
This project, we provided only Excel sheets. We didn't have to model everything in the module. We would only model what tie-ins we needed and such in structural steel. So once we quantified it, we would take the spatial data, put it in an Excel sheet, and that was the actual deliverable sign-off that the client got. And then obviously to construct the work packs, we use ConstructSim, and that's how we got our initial base point or starting locations, we'll say.
Thank you. Where do you see room for improvement in your workflow for scanning, and what would you like to see improved in the hardware or the software?
Faster scan times would be nice. Go ahead, Brad. What do you think?
Well, one of the challenges for this project was the fact that our client requested that we have something in Excel sheet format. So we just basically have a northing, a westing, an elevation, and then variances for those. To kind of change our workflow, I would say more keeping it on the 3D line, staying within that scan model, or as one of the questions was asked, scanning existing structure to engineer something to be tied into it, keeping it on the 3D side of things. Yeah. I understand that in the real world and when constructing things, 2D drawings are much easier for people at this time, but workflow-wise is to keep going the 3D road.
Yeah, 3D is almost instantaneous when you compare point cloud to your 3D model. Once you end up having to extract data out and put it in Excel format, there's obviously more room for error. And then you have to obviously have more than one person look at it, or if you get erroneous data, was it a keystroke error? Or that was a good thing about the point cloud data, was if we had any of that, we could go back and look at it again. It wasn't just something written in a field book. We could get back into the file and look at it and say, oh, we did type it in wrong, well, this is what it really is. So
I'll just make one more comment on that as well, and obviously I'll throw in the 4D with time. Obviously it's a big talk nowadays in BIM, and Chimbro as a construction company, this is really the road that we want to travel, because there's a lot of engineering firms out there that are really putting projects together that involve 3D, 4D, time, things like that. So, this is definitely helping us prepare to work with them.
Great. Thank you. Next question. Let's see. Are pipes from different modules connected directly together, or is there a spool piece used between them?
No, they're connected directly together.
For projects where you create a 3D CAD model, about how much time do you spend modeling for each day that you spend scanning?
Typically, myself and my crew, we typically can't get any faster. If we spend a whole day in the field, it's typically 2 to 3 days in the office to get to a final deliverable that we can turn over to a client.
Let's see. Thank you. There's people here who want a little more clarification on, are you saying that the original design documents that you were given were 2D drawings?
Yes, they were.
Well, the client had used ConstructSim, which is a 3D modeling program. So what they would do is provide, which we have 2 different teams, and I kind of look at it this way, is they'd provide the modules in 3D, and Seth and those guys would actually go out and verify that those modules are being constructed to match the 3D model.
The reason we say we go back to 2D in the Excel sheet is the fact that on this project, ConstructSim and Leica 3D scanning, we're not talking for this project.
Right, compatible. And they're looking in the future of those things to talk together.
That's right.
So would it have helped if the Cyclone software or the AutoCAD software could do the tolerance checks for plumbness and so on automatically?
Yeah, it would definitely take a lot less time if we wouldn't have to, click and look at and analyze and model certain parts. If it would just use the raw data, that would be awesome.
Do you ever use laser scanning to compare as-built versus design? Yep, no, we've done that a lot. And this is kind of what it is. Obviously, we ended up quantifying it in an Excel sheet, but
We've done some work lately on some other projects that, yeah, we'll actually build a 3D AutoCAD model and dump it into Cyclone and get the actual point cloud overlaid onto it, and it's pretty nice. It works pretty well.
You stated that processing time was close to instantaneous. We have been told the processing can take many hours or even a day to complete. How did you speed up your processing time?
I think your processing time is, I don't know where you break off processing time. Once you dump your point cloud data into your desktop or wherever you're working at it, it's available to your fingertips and you can analyze data right there. If we had an issue and like a superintendent on our site thought they had an issue, we could analyze that right away. We wouldn't necessarily have to do the entire sign-off before we could tell them what the issue was or where they were at.
That's right. To do a full deliverable for the client, as we've said before, that surely isn't instantaneous. Like Seth just said, the quick problems was instantaneous, but to get all the noise cleaned up and data points out of there that you don't need and extracting data points that you do need or modeling steel or pipe, obviously it was not instantaneous. It did take time.
Thank you. Do you use clash detection on any of your projects?
We've started to dip into that a little bit, and it seems to work fairly well. We didn't have a lot of ramp-up time on this project to incorporate that into our workflow for this project. But yes, clash detection does work.
When you compare 3D AutoCAD models to as-built laser scans, how do you verify tie-in points, visual or reverse clash detection?
The tie-in points actually have spatial data incorporated to them. Actually, if you build your 3D model and put it on the same comparable grid, then you can actually quantify that data just as a regular conventional survey.
Yeah, most of our work is all done traverse method. We rarely free station, so obviously most of our work will be done on local grid using Northern 5000, Easting 5000.
Let's see. I assume that these modules were bolted down in the field after delivery. Did you have to verify footings or bolt down locations at the site, or was that layout assigned to others?
Yeah, that was assigned to others. There was talk in the beginning that we were going to go down, and obviously it would supposedly been in our best interest to ensure that it would fit up. But in the conflict of time and my small crew, we were actually here on site at our brewer facility all the time, and yeah, that responsibility went to somebody else.
Okay, well, that is all the questions. Obviously, there was a lot of interest in this, and I think your small crew has done quite a bit, in fact. So I just want to thank all of you for joining us the past 45 minutes or so, and a real special thanks to Seth and Braden for sharing this case study with us. And I want to remind everyone that we have recorded it, and we'll be putting it back up on fiatech.org in the media library later this week. And I hope you'll be able to join us next week for a presentation by Target on their replica building guidelines project. So with that, thank you once again, Seth and Braden, and everyone have a great day.
Thank you, Nicole.
Thank you.
Bye-bye.